So today we are going to learn what is longest consecutive sequence. Let's try to understand what is consecutive sequence first. I say what is largest consecutive sequence. So here we have given an elements 1, 2, 3, 4. Yes, like that, right? So I say 1, 2, 3, 4. This give me the length of 4, and I say 100, 101, and 102. This will give me the length of 3. So the highest length is 4. So this is going to my largest consecutive sequence, and we should need to return this length, return this answer. This is my answer. We should need to return this length. So this is largest consecutive sequence. Okay, let us try to do this using brute force solution. So let us start from the brute force solution. I say brute force solution. So what can I do for the brute force solution? I say longest is equals to, I say longest is equals to 1. I say longest equals to 1. Then I say uh, I'll take x, then I start iterate my array, and I go to first element, that is 1 or 2. And when 1 or 2, when x equals to 1 or 2, then I say I'll take a counter here. Okay, let me move this place here. Yeah, I'll take a counter. I'll take a counter. So it is when x will become 1 or 2, then it's going counter is increased by 1. Okay. What I need to do when x becomes 1 or 2, I should need to look for 1 or 3. What I'm gonna do is I'll do a linear search, and I check the array if the array contains 1 or 3 or not. I'll do a linear search. If the array contains 1 or 3, no, the array does not have 1 or 3, right? If the array does not have 1 or 3, what I'm gonna do is if the array does not have 1 or 3, so I'll move the element. I'll move then 4. Now my x will become 4. Now my x is 4. Then I increase the counter by 2. Then I say 4. Is 4, is there any, when I do a linear search, if did I get any 5 in the next element, that is 5, right? You just need to get the element that is 5. Is there any 5 in the array? No, there is no 5 in the array. So then I move. So I've got 100. Then I got 100. If I say x is equals to 100, then x is equal to 100, then I say, then what will be the next element? The next element will be 101. Is 101 there in the is 101 there in the array, given array? When you do a linear search, if you find the 101, yes, there is 101. Okay. If there is 102, yes, there is 102. Yeah, there is 102. Right. The next element, that is there is 102. Yes. Is there is 103? No, there is no 103. There is no 103. Here, up to here, the count will be, the count will be 4. Right. No, the count will be 3. So I say 3, count is 3, and I update the longest to 3. Okay. Then I move. I've got 1. Now the x will become 1. Then the next element I look for, that is 2. 2 is there in the given array? Yes, there is 2. We find out this using linear search, and I look for 3. 3, yes, 3 is there. And I look for 4. Yes, 4 is there. And I look for 5. No, 5 is not there in the array. So 5 is not there in the array. So up to here, I get the count that is 4. I get the count that is 4. Then I update my longest. That will be 4, right? That will be 4. My longest will be 4. So this is my answer. So yes, this is my answer. So let's try to write a code for this. Say code. Then I initialize longest is equals to initialized as 1. Then I write a loop, that is I equals to 0, I is less than n, and I will increment. Then I say x is equals to, my array of I, right? Here x will become my array element, right? Here x has become my array element. Then I say, then if when it will become array of I, then my count will become 1. Count is updated to 1, right? Here count is updated to 1. Then I'll write a, oh, what's wrong? I say y plus plus. Okay. and I say I'll write a while loop. I say I'll do a linear search. I do inappropriate to find the next element. To find the next element that is 103. To find the next element that is 103 in the array. Then I say array x plus 1 to find the next element is equal to true if it exists. If the element 103 exists, then I say x is equals to x plus 1, and the count and the counter will be count plus 1. Yeah, counter is. So okay, I'll do a linear search here. That is I'll start the iteration, that is I equals 0, I is less than n, and I is I plus plus. So then I say if array of I is equals to n, the number, then I say return true. Then I say return true, otherwise return false. Otherwise return false. Yeah. So this is how the linear search used to work. Let us try to analyze time complexity. This time complexity will be take for this loop, that is time complexity is big of n, and for this it will go like big of n as well. You know, this is says linear search, right? Big of n, we can say now the time complexity is big of n, big of n into big of n. So the time complexity is now near about big of n square, near about big O of n square. Why I say near about big O of n square? So let's try to take an example. If I take 1 2 3 4 5 as my array, then x will become 1. If I start iteration from 1, then x will become 1. If x contains 2, the next element 2, yes, it contains. It contains next element 3, it contains the next element 4, and it also contains the next element, that is 5. Yes, okay. Then I move, then x will become 2, then it will become 3. Yes, it has 3, it has 4, it has 5, and it's go on. For that, the time complexity is near about 5, near about big O of n square, right? And the space complexity will be like big O of 1, because we are not using any extra space, no extra space. So we're not using any kind of extra space at all. There is no extra space. So this is the brute force solution for the longest consecutive ones. So okay, now we are going to look for the better solution for this. Now we're going to look for the better solution. So to achieve the better solution, what we need to do is, we have given an array. I have taken array here. I've taken a big array here. Okay. Then I say I should need to what I did here is I have sorted the array. I've sorted the array. The array will be look like this after sorting. So what I'm going to do is I say longest. I'll take a longest is equals to 1. My longest will be 1, and I take the last smaller element is equal to its initially most possible minimum value. The last smaller contains the most possible minimum value. It contains the most possible minimum value, and I say and I also take another one, that is my current count. I say count my current. So it is going to count my current one. So okay. So I have 3 here. Why did I try to sort all of this? Because once I've sorted all of this, then I get all of the elements like 1 2 3 4. I've got this in a sequence. I got this 100, 101, 102. So I've got all of these in a sequence. For that I just have sorted the array, right? Okay, for that I have sorted the array. So let's try to do the iterate the array. I'll go to 1. I'll go to 1. I'll go to 1. When I go to 1, I'll update my current counter to 1. Current counter will become 1. My last smaller element, that is minimum possible value. That is a minimum possible value. It can be anything. A minimum possible, it can be anything. So I'll just update it to 1. Now my last smaller is become 1. Okay. Then I move. It's again 1, but I'll check. So how I'll check for, I've go to 1. Then I say Is there any one in my sequence? I say in my sequence, is there any one? Yes, one exists in my sequence, right? If there is one exists in my sequence, so this is not going to be part of my sequence because my one is exist in here, right? I have got my one here, so it cannot going to take a part of my sequence. For that, what I'll say is I'll move again same one. I have got one in my part of sequence, so I don't take it. I'll go to two. So okay, two. When I have two, when I got the two, what I look for? I look for the I look for the one because I look for the one. What I look for the one, the previous element. I look for the previous element, that one. Did I have the previous element did I have the previous element in my sequence? So this is my sequence. This is my sequence. Did I have previous one in my sequence? Yes, there is a previous one in my sequence. Previous one in my sequence. So I'm going to take this two. I'm going to take this two. I'll say then I'm going to take this two. Then the counter will become 2 and the last smaller also will become 2. Then my longest is also updated to 2. Then I move 2. When I have got 2, but there is I have 2 already in my last previous element, right? I have last smaller element as 2. There is 2 in my sequence, so I'm not going to take 2. Then I move. No, I don't take 2 because the 2 is already there in my sequence. So then I move. I've got 3. I've got 3. What I do is I'll check for when I got 3, I check with the previous element. Did I look for the previous element? Did I have 2? Did I have 2? Yes, I have 2 in my in my sequence. Yes, I have 2 in my sequence, right? I have 2 in my sequence. So I'll take 3. I'll take 3. Then I increase the counter to 3. Then my last smaller will become 3 and my longest is also updated to 3. So this is how it works. Then I move. Let me erase this. And 3. Again 3. 3 is already there in my sequence. So I'll just avoid it. I'll just avoid it. Then I move 4. Yes. When I have got 4, I'll look for the previous element. Previous element was 3. Is there 3 in my sequence? Is there 3 in my sequence? Yes, I have got 3 in my sequence. So I'll take it. So what I'll say? I'll take it. Then I increase my counter to 4. Then my last smaller element will be 4. And I update my longest is equal to 4. Then I move. Okay, I have got 100. I take 100. I've got 100. If I have got 100, then what should I look for? What will be my previous element? My previous element will be 99. What will be my previous element? If I have got 100, what should I need? What should the element do I look for? I should look for 99. If my value is 100, I should need to look for the previous element, that is 99. But in my sequence, did I have 99? No. In my sequence, I have 4. I didn't have 99. So what I do here, I'll start from new. What I do here, I'll start from new. Then it will be like, I'll start from new. Then it will be like my last model will become 100 because I'm starting new. Then my last element will become 100. When it will become 100, then my current value will become again 1. It will become again 1. Then I move. I've got 101. When I have 101, what element should I need to look for? 100. Did I have 100 in my sequence? Yes, I have 100 in my sequence. Then I'll take this. Then I take this. Then I increase my current count. I increase then my last smaller will become 101. Then I move again 101. But 101 is already there in my sequence. I'm not going to take this. Then I move 102. Okay, 102. Yes. If I want to take 102, what should I look for? I should look for the previous element. What element we should need to look for? I should need to look for the 101. Did I have 101 in my sequence? Yes, I do have 101 in my sequence. I do have 101 in my sequence. So I'll take it. I'll take 102. Then I increase my counter to 3. Then I've got the 102. I've got the 102. Okay, the iteration is over. The iteration is over. Since the iteration was completed, so when the iteration is completed, I have got the longest element. I've got the longest length as my answer, that is 4. That is 4. This is my answer. So okay, let us try to code this thing as a code. Yeah, let's try to code this thing. So what we should need to do here is, first we should need to sort the array. We should sort the array. Okay, after sorting, I say longest is equals to be 1. Longest is initialized 1. Then I say my current, my count current will be 0, initialized with 0. And I say my last small number, my last smaller will be int of min. That means it contains the most possible minimum values. The last smaller is assigned with the most possible minimum values, and I start the and I'll write a loop. I is equals to 0 and it will go up to n. Then I say here, I'll write a condition here. Then what I'm going to say is, if I've got element, that is, if my array element is -1, is less than 1, is equal to last smaller, right? Equal to last smaller. When the previous element is equal to last smaller, then I say count is equal to count plus 1. Increase the count. Then I say last smaller. Then my last smaller is equals to array of I, is equals to array of I. Okay. If array of I is not equal to last smaller, if it's not equal to last smaller, then it will be the same. That is, then I say count is equals to count plus count. Then my counter will become 1. Then I say last smaller is equals to array of I. Yes, it is array of I. Okay, it is array of I. At last, what I say is, then my largest is equals to max of my longest. So this is not largest, this is longest. We are not using any. Yes, I say longest of the current counter. We say count current, right? Yes, we count current. Yes, so this is how it works. Okay, let's try to analyze the time complexity, because we are using sorting here, because we sorting the array. When we are sorting the array, the algorithm, then the time complexity will be like big O of n logarithmic of n. Yes, because we are using sorting, and for this single for this iteration, we've got big O of n time complexity. That'll be like big O of n. So this is my time complexity for the better solution. So now we are going to discuss about the optimal solution. For the longest consecutive sequence. So in longest consecutive sequence, for the optimal solution, I'm going to use a set data structure. So okay, as it is a set data structure, I'm going to insert the elements. I say 102, put into the set, 104, put into the set, 100, put into the set. I'll say 1, put into the set. I'll say 101, put into the set. And I say 3, put into the set. I say 2, put into the set. I say 1, no, because array contains because the set contains unique elements. We shouldn't we shouldn't have to repeat the elements. Only set contains only unique elements. Then I say one, no. So the iteration is over. We've put everything into the set, right? We've put the elements into the set. Then I say once iteration is over, then I'll iterate in the set data structure. In the set, I'll start iterating from the set, and I go to here, and I go to 102. I say 102. Yeah. Okay. I'll take a longest here. Longest is equals to. So okay, probably I didn't initialize anything. I say longest, and then I say if 102. Yeah, 102. What should I need to look for? So okay, I say we have 102. Do we have 101? Do we have 101 in the set? Yes, we have 101 in the set. Yes, we have 101 in the set. So okay, it's like 100, 101, and 102. I was here. I was here somewhere in the middle of the set. I was somewhere in the middle of this set. Did I should need to take one not I should need to start from 102? No, I should not have to start from 102. Then it will be seems like a brute force solution. So, right, we shouldn't use that. Yes, okay, it's 101 and 100. So what I'll do here is I'll stop. I'll stop. I don't take this. I don't take. Then I go to the next one. 4. Did I have 3 in my set? Yes, I do have 3. I do have 3. Then I probably don't use this. Then I don't start from here. I don't start from here because we have 3. I don't start from here. Then I'll go to the next. We have 100. Did we have 99? Did we have 99 in the set? No, there is no 99 in the set. There is no 99 in the set. Then what I do is I look for the next element. Then I look for the next element, that is 101. Yes, we have 101 in the set. We have 102 in the set. Do we have 103 in the set? No, there is no 103 in the set. There is no 103 in the set. Then I say counter is equals to 3. Then I update my longest as 3. Yes, okay, it was done. Then I'll move to next. I have got 1. Did I have 0 in my set? No, there is no 0 in my set. There is no 0 in my set. Yes, I look for the next element, that is 2. I look for the next elements, that is 3. I have 3. I look for the next elements, that is 4. Yes, I have 4. I look for the next element, that is 5. Did I have 5? Did I have 5? No, I didn't have 5 in my set. I didn't have 5 in my set. So I won't take it. Then the counter will become 4. Then count will become 4. I'll update the longest to 4. Now the longest has become 4. Yes. Then I'll move. I say 101. Did we need to perform 101 again? No, we have checked here. We have done here. We have checked here, right? Did I should need to check this again? No, there is no use for checking this again. I avoid it. I'll move to the next. 3. Okay, 3. I have checked for 3 here, right? I have also checked. I have checked this. 3 is also here. I have checked for 3. I have checked for 3. This I should need to check this again. No, I shouldn't. There's no use for checking this. There's no use for checking this again. Then I move. Then I stay 2. Did I have any use to checking for 2? No, it's already had been checked here. It's done. So I don't take it. I don't check it again. There is no use. So the iteration is over in the set. If the iteration is over in the set, we have got the longest as 4. We've got our answer. We have got our answer. So let us try to discuss about the time complexity. Time complexity will be big O of 1 if it is a unordered set. If we use unordered set, then the time complexity will be big O of 1, right? The time complexity will be big O of 1. So okay, what if, so okay, we'll go to the code. Then the time complexity will become big O of n, because we use a for loop. Then I say big O of n. because we iterate the array, because we iterate the map. We iterate the map. First we iterate the array, then we first we iterate the array and put the elements into the set. Then we iterate the set. Then it'll be like big O of n, right? Like that, n plus n, and another n. You can say another n for while loop, for checking, for counting, that you can say in that way. So we shouldn't consider that. We shouldn't consider that. Then it'll be like we shouldn't consider that, right? So let's say in first we have how many iterations we do here in the set? 1, 2, 3, 4, 5, 6, 7. So there are 7 iterations we have did here. As is 7 plus we have checked for this 101, we have checked for this 102, we have checked for this 103. Then it will be like 3 plus we check for 1, we check for 2, we check for 3, and we check for 4. Then it will take 4 iterations. Then it will be 14. Then the time complexity will approximately, it'll go big O of 2n, right? It'll go approximately big O of 2n. So okay, then the time complexity will be like big O of time complexity will be like 2n plus n is 3n. This is my time complexity. This is my time complexity. And what will be the space complexity? So I say the space complexity will be big O of n, because we are storing elements into the set. We are using a space that is set, right? Then the space complexity will become big O of n. So this is my optimal solution for the longest consecutive sequence. Yes.